So our next unit is electric heating. Okay. So electric heating is a process in which electrical energy is converted to heat. Okay. So whenever we utilize electrical energy for heating, okay, the process of using electrical energy to convert into heat is known as electric heating. So heating is required both for industrial purpose as well as for domestic purpose. So if you see here in these images, in the industries, heating is required for melting metals, for molding of glass, okay, enameling of copper. Okay, these are copper strands. Enameling of copper, baking of insulators. You can see, if you carefully observe this image, you can see mortar is placed here within this. So in order to bake the insulation that is provided to these mortars, this electrical energy used for heating the insulation. Okay, and for even for welding purpose also electrical energy is used. So if you go to see the what is the need in the domestic side, for domestic purpose, heating is required for cooking, for heating water, for room heating. Okay, so of course in our side of India, we don't require any room heaters during winter, but in northern side of India, northern people, they definitely require room heaters during winter. Okay, and pressing for pressing clothes also we need electrical energy. There are many more applications you people know. Okay, so I need not go on telling the applications or the uses of electrical energy. People already know. Okay, so there are many advantages of using electrical energy for heating purpose. Okay, 1 minute. So one of the advantages, it is very economical. Why? Because electrical heating equipment is cheaper. Electrical heating equipment do not require much skilled person. Okay, therefore maintenance cost is less. Other advantage is cleanliness. Okay, since dust and ash are completely eliminated in electrical heating. Okay, so it keeps surrounding clean. Next advantage is it is pollution free. As there are no flue gases in the electric heating, atmosphere around is pollution free. No need of providing space for next exit. Okay, means usually if you might be already knowing, if we are using some means non-electric for example coal for heating, then the fumes that are coming out of the coals must be provided with some exit to send them into the atmosphere. Okay, so such exits are not required for electrical heating purpose. So it is very easy to control. In this heating, temperature can be controlled and regulated accurately either manually or automatically. Next advantage is uniform heating. The substance can be heated uniformly throughout, whether it can be conducting or non-conducting material. Okay, so we can heat conducting material as well as non-conducting material. Okay, and the heating can be provided uniformly throughout the material, whichever material you are heating. Okay, next it has high efficiency. Okay, so if we use a non-electric heating, for example coal, okay, only 40 to 60% of the heat is utilized. Okay, for heating purpose. Okay, but in electric heating, 75 to 100% of the heat can be successfully utilized. So overall efficiency of electric heating is very high. Next one is automatic protection. So protection against overcurrents and overheating can be provided by using control devices in electric heating. So if you are using control devices, you can easily protect against the overcurrents and overheating. So automatic protection can be provided in the case of electric heating. Next advantage of electric heating is heating of non-conducting materials. Okay, so the heat developed in the non-conducting materials such as wood or porcelain is possible only through the electric heating. Okay, so next one is better working condition can be obtained. No irritating noise will be produced in this case of electric heating. Okay, and also radiating losses are low in the electric heater. That's why it provides better working condition. Less floor area, it occupies very less floor area. Okay, because it is compact in size. You can make it as compact as required depending on our requirement. Okay, so it occupies very less floor area. Next is high temperature. Okay, so means our purpose of electric heating is we want to raise the temperature. Okay, for so and so purpose depending on the requirement. Okay, so as high as possible temperature can be increased. Okay, so high temperature can be obtained by electric heating except the ability of the material to withstand it. Okay, so if I want to heat any material to so and so, if I want to melt a certain material, okay, so we might be knowing the melting point of that material. So till it reaches to its melting point, the heat of the that material can be increased. I mean, the temperature of that material can be increased by using electric heating, and we must make sure that at certain temperature any material will get burned. Okay, so we can control the temperature, but we can raise the temperature depending on the material which is to be heated, already knowing that whether it can withstand the heat or not. Okay, so these are all the advantages of electric heating. Now let us see different modes of transfer of heat. So you might be already knowing all this. Huh? Okay. So the transfer of heat from one body to another because of the temperature gradient can take place due to these three modes. One is conduction mode, next one is convection mode, next one is radiation mode. Okay, so you can see an image there. In this image, you can see first one is conduction. So a person here is boiling some water, for example, in a vessel. Is holding the handle of the vessel, and if you observe carefully, the person has is holding that vessel at a height where the flames which are coming from the coal maybe okay are unable to reach the vessel, means they are unable to touch the vessel. Okay, the flames are not touching the vessel which is to be heated. Okay, so now so, first of all, okay, let us start with conduction. Okay, so a person is holding the vessel, the handle of the vessel. So, if the water is getting heated up, then definitely the heat will be transferred to the handle also. And the person whoever is holding that handle with his hand, definitely the heat he can feel that heat. Okay, so the transfer of heat from one substance to another due to the direct contact is known as conduction. Okay, so from one substance to another substance, if heat is transferred due to direct contact, okay, is known as conduction. Okay, so that's why in our houses insulating materials will be provided to the vessels, to the handles of the vessels. Okay, so that we can hold the vessel even if the vessel gets heated up, this insulating material, that heat will not be absorbed by this insulating material. Okay, nowadays the technology has evaluated in such a way that in my house I have some vessels. For example, it's one brand is well-known brand, that is Hawkins. So I have a pan, Hawkins pan with a handle. Okay, for that they have given a steel handle. That steel handle has a hollow inside it. Okay, so it's a completely hollow. Hollow, you can say a cylindrical hollow tube-like handle is there. Okay, so they have not provided any insulation to that material. Okay, to that handle. Simply, they have mentioned up to what distance I can hold the handle with my bare hand. and I will not feel the heat. Okay, so they have given some marking, and since the tube is hollow, means that handle is hollow, the air will be continuously circulating within that handle. Okay, so the air goes in and takes away the heat. Okay, the air surrounding it inside the room. Okay, in my house, it will be continuously taking away the heat of that handle because that is hollow. Okay, so the technology has evaluating a lot. Means they are trying to develop in new ways of avoiding conduction. Okay, so without even providing any insulating material, okay, we will be able to hold the handle. Okay, if you I have two more another method vessels also, I can't explain now about that. Okay, so they don't have insulation. Okay, without providing any insulation to the handle, I'm using some vessels in my house. They are food grade materials. Okay, so that's why I have bought them. Okay, so if you can, if whatever vessels that we use in our houses, they should be food grade. Okay, so if you are not using food grade, you just go through the internet, search for the food grade material and buy such vessels so that you will have good health in future. Okay, so forget about it. So here, see if the transfer of heat is from one substance to another substance due to direct contact, that is known as conduction. Okay, and convection means if you see here, water is boiling. Okay, so initially the water which is in the surface of the vessel will boil. Okay, and the water, when water boils, the molecules just starts, they get lighter and they will start moving upward. Okay, when they starts moving upward, the molecules in the fluid, upward molecules, will also get heated up. Okay, so next one is convection. Convection means transfer of heat through a fluid caused by molecular motion. Okay, you can observe here the molecules are moving. You can see some arrow marks here. Okay, so the molecules are moving up. Okay, so due to transfer of heat in the fluid caused by molecular motion is known as convection. Okay, next is radiation. So if you see, the vessel is not kept on the flame. Okay, it is not kept directly, it is not in contact with the flame. So conduction is not there. Due to direct contact, if heat is transferred, that is known as conduction. Okay, even if molecular motion is there, that is convection. So no molecular motion in between this vessel and this flame, as well as there is no conduction between the vessel and the flame. Okay, so here there is an empty space between these two, but this water in this vessel is boiling. That is due to radiation. So what is radiation? If the energy is radiated or transmitted in the form of rays or waves or particles. Okay, you can see some arrow marks, red color arrow marks are there. So if the energy is radiated or transmitted in the form of rays, waves or particles is known as radiation. Okay, so this is briefly about conduction, convection and radiation. Conduction means direct heat transfer due to direct contact. Convection means due to molecular motion heat transfer. Radiation is without any direct contact. If the heat is transmitted in the form of rays or waves or particles, that is radiation. Let us discuss in detail about this conduction, convection and radiation. So, in conduction, let us start with conduction. In conduction, if one molecule of a substance gets heated and transfer the heat to the adjacent one and so on. Okay, so one molecule gets heated up and it transfers the heat to the next molecule and so on. In this mode, heat transfers from one part of a substance to the another part without the movement in the molecules of the substance. Okay, so in the case of conduction, molecules will not move. Simply, they will transfer the heat from one molecule to the another molecule. Okay, so the rate of the conduction of heat along the substance depend upon the temperature gradient. Okay, so that temperature gradient is given by Q is equal to K into A by T into T1 minus T2 into T. Are you able to see my presentation? Can anybody inform?
Yeah.
Yes?
Yes, ma'am.
Yes. Okay, I'll continue. So now, so the rate of conduction of heat is given by Q is equal to Ka, okay, by K into T1 minus T2 into T, where small t is the thickness of the material in which you want to heat some substance. Okay, so thickness of that material. A is the cross-sectional area of the two parallel facings of that particular vessel or substance, okay, in which you are heating some other substance, okay, and T1 T2 are the temperatures of the two phases in degree Celsius, and capital T is the duration of heat transfer in hours, and small k is the coefficient of thermal conductivity of that material, okay, which is measured in megajoules per meter square per meter per degree centigrade per hour. Okay, so for example, conduction, examples of conduction is if I am holding, see, I am holding an metallic substance in in my hand. I have kept that metallic substance on the flame. Okay, so you can see the red portion. The metal gets heated up, and gradually the heat is transferring towards my hand. You can see the red portion is gradually increasing. You can see the arrow mark here. So, without any molecular movement, heat is transferred. Okay. So, examples are refractory heating. So, here this is a ceramic body. Okay. In this, without any molecular movement, the heat will be transferred from one molecule to another molecule within the ceramic body. Okay, so this is the refractory heating. And next one is heating of the insulating materials of the machines which are manufactured. You know, whenever machines are manufactured, they are provided with proper insulation, and they are placed into some baking equipments. Okay, there in that baking equipments, resins are filled. The resins are there. They will be in liquid form. The resins will be in liquid form. They will be allowed to flow within the equipment in all parts of the equipment, and they are baked so that the resin becomes solid material. Okay, so proper insulation is provided to each and every equipment of the means power system actually. Okay, so each and every part of the equipment is fully insulated, not avoid the leakage of current whenever it is utilized. Okay, so next one is convection. Next one is convection. So let us discuss about convection. So, in this mode of heat transfer, the heat transfer will take place from one part to another part of a substance or a fluid due to the actual motion of the molecules. Okay, due to actual motion of the molecules, heat transfer will take place from one part to another part of the substance or fluid. Okay, so the rate of heat depends upon, the rate of heat transfer depends upon the difference in the fluid density at different temperatures. Okay, so the fluid density will be varying as the temperature varies. So the difference in the, it depends. The rate of heat transfer will depend on the difference in the fluid density at different temperatures, and the quantity of heat absorbed from the heater by convection depends on temperature of the heating element above the surrounding. Okay, so the quantity of heat that is absorbed from the heater by convection method, it will always depend on temperature of the heating element above the surrounding, size of the surface of the heater, and on the position of the heater. At what position heater is placed, what is the size of the surface of the heater, and the temperature of the heating element. Okay, so the quantity of heat absorbed by these molecules will depend on all these factors. Okay, so the heat dissipated in this case can be measured by a formula that is given by H is equal to A into T1 minus T2 into B. Okay, where this A and B are the constants, they will depend on the heating surface. T1, T2 are the temperatures of heating surfaces and fluid. Okay, so this is example is immersion water heater. In this, most of you will be using this immersion water heater in our houses. Most people use this. I won't use it. Okay. So there are some drawbacks actually. Um, that's why I won't use this immersion type water heater in my house. Okay. So whenever we want to buy any equipment, so we must know the pros and cons of that equipment so that in future it should not cause any side effects to our health. Okay. Next one is radiation. So in this mode of radiation, the heat transfers from source to the substance to be heated without heating the medium in between. Okay. So heat is transferred from the source of heat to the substance to be heated without heating the medium. So it depends on the surface. Rate of heat radiation is given by some Stefan's law. Okay, so the formula that this Stefan has given is H is equal to 5.72 into 10 to the power 4 Ke T1 by 1000 whole to the power of 4 minus T to the 1000 to the power of 4. Okay, so T1 is the temperature of the source and T2 is the temperature of the substance that is to be heated. K is a constant known as radiant efficiency constant. E is the emissivity. Okay, so examples for radiation is solar heaters. Okay, so we know in between sun and earth vacuum is there. Okay, so there is no mode of there is nothing available to transfer the heat. Okay, so simply due to radiation heat is transferred. So the solar heaters are able to heat the water only simply by absorbing the heat due to radiation from the sun. Okay, so these are the different modes of heat transfer. So let us discuss design of the heating element. Okay, so if you know the voltage and electrical energy input, okay. So what is the voltage and the supply voltage and the electrical energy input? The design of the heating element for an electric furnace is required to determine the size and length of the heating element. Now, you know the heating elements are utilized in industries as well as in the domestic purpose for domestic purpose also. But first of all, we must design the heating elements. Okay. So in order to design the heating elements, we need some heating furnaces. Okay. So of course, in the heating furnaces, if I am using, for example, if I want to mold an electric glass, okay. So if I want to mold an electric glass, so those electric glasses are molded in the heating furnaces. Okay. So in those heating furnaces, heating elements will be there. Okay. So these heating elements must be initially manufactured. Okay. So depending on the voltage and the voltage that is given to these furnaces. Okay, so the heating element, it can be either wire type, it can be either circular type or ribbon type heating element. Okay, you can see here, this is the ribbon type heating element, this is the circular type heating element. Okay, so ribbon type heating element permits the use of higher wattage per unit area compared to circular type heating element. Okay, so you for means higher the wattage rating of the ribbon type heating element will be more when compared to circular type heating element. Okay, so let us discuss circular type heating element. You people start writing along with me. So, all these terms must be written in your notes. Okay, so let us how to means we must know the length and width of the heating elements. Means how to design the heating element you must know. Okay, so what should be the rating of the heating element? Okay, depending on whether it is um, circular type or ribbon type heating elements. So you must know the length and diameter of the heating element depending on the voltage that you are going to give, depending on the heat up to which the heating element is to be heated. Okay, so in order to determine the length and diameter of the heating element, okay, so let us, there are some equations. Okay, now, So the when the heating element is connected to the supply, temperature, what will happen? And heating element, when supply is given to the heating element, what will happen? The temperature of the heating element will gradually raise, and finally it will reach to a very high temperature. So let us assume V is the supply voltage and R is the resistance of the heating element. Okay, then what is the electric power input? P is equal to V square by R. If people also write, if people start writing these equations, okay, along with me. As I am telling you, people start writing. Okay. No need to write all the theory, just write down these equations. Okay, now you already know what is resistance. R is equal to rho into L by A, where L is the length, A is the cross section of the, I'm sorry, area of cross section, and rho is the resistivity. Okay, so what is the area of a circular element cross sectional area? It is pi r square. So if you know the diameter, it is pi d square by 4. Okay, so rho into L by A, you can rewrite as rho into L by pi into d square by 4. So this is my R. So substitute R value in the above equation, P equal to V square by R. You will get some other expression. Okay. So if you substitute it in the above equation, I hope you have written. I am changing this one. So if you substitute it and if you rearrange the terms, okay, you will get P is equal to V square pi d square by 4 rho into L. Okay, consider it as equation number 1. Okay, now rearrange these terms. If you rearrange these terms, it will be L by d square. You will get L by d square is equal to pi into V square by 4 P into rho. Do you know all these terms I have written here? No need for me to explain all these terms, isn't it? You already know. So you will get L. This is L, isn't it? This is, I'm sorry. This is looking like as if it is 1 by d square. It is not 1, it is L. So L by d square is equal to pi into V square by 4 into P by rho. Okay, I'm waiting for you to write that sort of events. I hope you have written. Don't write all the theory, only write only equations. And you know, according to Stephen's law, H is equal to 5.72 into 10 power 4 Ke. T1 by 1000 whole to the power of 4 minus T2 by 1000 whole to the power of 4. Okay, so you know the heat dissipated per unit area given by Stephen's law. Okay, and since you have used a circular heating element here, you already have already shown you the circular heating element image. Okay, so the cross sectional will be circular. So the surface area of the circular heating element is given by pi d L. Okay, surface area is pi d L. So the total heat dissipated will be equal to the heat dissipated per unit area into the surface area. Okay, so into the surface area. So I hope you have written this H is equal to so and so and S is equal to so and so. Okay, so the total heat dissipated will be this surface area into the heat dissipated per unit area. So next slide. So total heat dissipated is pi dl into H. Okay. So under thermal equilibrium, power input should be equal to the heat dissipated. So what is the power input P? So heat dissipated is what? Total heat dissipated pi dl into H. So that is it. Okay. So H into pi dl is it. Okay. This is our equation 2. Okay. Now substitute equation 2 in equation 1. Okay. Instead of P, where there P is there in equation 1. Okay. Just substitute it. You will get V square pi d square by 4 rho L is equal to H into pi d L. Okay, just rearrange these terms. You rearrange the terms in terms of d by L square. You will get d by L square equal to 4 into rho into H by V square. Where H is the heat dissipated, total heat dissipated, and of course H is the heat dissipated. Total heat dissipated is pi dl into H. Okay, so H is the heat dissipated, rho is the resistivity, V is the supply voltage. Okay, so you can determine the diameter of the heating element as well as length of the heating element if you know these terms. Okay, so by solving the above equation, you can determine the diameter of the wire as well as length of the wire. Okay, so we have very less time left over because I started my class very lately. So my class was late today because of connectivity issue. So one more, I want to complete this ribbon type heating element also. The length and width of this ribbon type heating element can also be determined, similar to the above circular heating element. Okay, I'm going to the ribbon type. I hope you have written. Even if you have not written, I'll show you while taking attendance. Okay, you can write while taking attendance. Now, let us assume ribbon type heating element. You know, so ribbon type heating element will have. Let us assume that width is W and T is the thickness of the ribbon type heating element. Okay, width of the ribbon element is W and thickness of the ribbon element is T. The electric power is what? Same formula, P equal to V square by R, and R you already know, R is equal to rho into L by A. So what is area? For ribbon type width into thickness. Okay, for ribbon type heating element, area is equal to width into thickness. So R equal to rho into L by A. A is what? W into T. So instead of here, write down W into T. Now you have got some expression for R. Substitute R in the above equation. Similar to your circular type heating element, substitute R value in the above equation. So you will get P equal to V square by rho into W into T. So you just rearrange these terms, you will get L by W equal to V square T by P into rho. Okay. Now, okay, you can not write it down later on while taking attendance. So I will show you later on. So the surface area of the rectangular element is what? 2 into L into width. Okay, surface area of this ribbon type element. Okay, so heat dissipated is total heat dissipated is heat dissipated into the surface area. Heat dissipated is H into 2LW. W is the width, L is the length of the ribbon type heating element. Now under equilibrium, thermal equilibrium, electrical input will be equal to the total heat dissipated. So electrical input is P and total heat dissipated is H into 2LW. Okay, so just here